Okay, what we're going to be taking a look at today is describing intervals. This is especially important for domain and range, so that's probably where you're coming from for this. If I started on the domain and range video, I definitely sent you this way just to kind of check this part out. When we're describing intervals, we're talking about sets of numbers basically, so rather than saying all real numbers, we're only interested in part of it. The main three strategies we have: you can use words to describe what's going on, what you're probably most familiar with, which would be an inequality, and the method that may be new to you, but I'm going to be stressing this year, is going to be interval notation. Personally, while it's a little new, so it can be a little challenging at first, I think interval notation is the easiest, in my humble opinion. So what we're going to do is rather than just writing out what the rules are, we're going to kind of do a few examples, so that way you can see what's going on here. So first example we're going to take a look at, I'm actually going to make the number line in green so that when I highlight it, we can tell what's going on. So I'm going to put a 0 in the middle. Let's go 1, 2, -2, 1, 2, 3, 4, 2, 4. Okay. Here's what we're going to do. Let's go open circle on -2, and let's shade in all the way to 4. I know this takes me a second to draw in. Alright, so suppose I had that interval. I wanted that set of points. Okay? Well, I've got a few ways that I can write it. If I wanted to use words, I might say something along the lines of all numbers from -2 to 4, including 4. I might say that. I might say not including -2. There's definitely different ways you could describe it. That'd be something that I think a lot of people would put down. So you can see it. It's not too bad. You're kind of just saying what's going on. Now, if I wanted to come down here and write an inequality, the key here is you think about the numbers that you want. That's where your x needs to be. So I want the stuff in the middle, and it has two boundaries. So I'm going to have a lower boundary of a -2. I want the stuff in the middle. I'm going to have an upper boundary of 4. And the key for writing my inequalities is that I have an open circle here. So if I have an open circle, that means that that point is not included, which means I don't want the -2. So I'm just going to write a less than symbol. -2 is less than x. On the flip side, my 4 over here is filled in. This is a closed circle. I want that 4. So I'm not just going to put the less than sign there. I'm going to put the equal to underneath. Right? So this statement altogether would say -2 is less than x is less than or equal to +4. That also might be what you say in words. A lot of times the word statement is just a direct copy of what the inequality would be. So this is probably what you're most familiar with. Take either one of those. But what I'm going to introduce you to is interval notation. And here's the way it works for interval notation. All I care about are the boundary points. Mathematicians are lazy. They don't want to write more than they have to. I don't want to worry about all this stuff in the middle. To me, that's wasted ink. Or if I was using a chalkboard, wasted chalk. I want to try to be more precise. So I still need those boundaries. I need those two numbers. -2, and we're just going to put a comma between it and put a 4. Okay? But now I need a way to distinguish between whether the point is included, like the 4, or not included, like the -2. And so the way we do that is the following. If the point is included, it gets a bracket, square bracket. If the point is not included, it gets a parentheses. All three of these are equivalent statements. This is the one that I'm going to encourage you to become more comfortable with. Describes the same boundaries, -2 to 4. If the point is included, it gets a square bracket. If the point is not included, it gets a parentheses. Okay? So, with that, let's take a look at another example. Okay? Example 2. Same thing, I'll draw the first one. Actually, this is going to be a pretty simple one. I'm going to draw a number line. I'm going to start at 0. And I'm going to do the following. I'm going to close dot at 0. And I'm going to fill in, including the arrow, everything to the right. Okay? And that's a common data set. You know, how many times do we have a time graph? Well, you start time at 0 and it goes on forever, right? So it's pretty common to have a domain that would be something along these lines. Now, first up, if we go to write words, we have to be careful, because if we just say positive, that's not necessarily including 0, right? So the best option we could put is we might say all non-negative real numbers, okay? If we just wanted to say positive, you'd probably also have to make some distinction that 0 is allowed. And that just depends on how picky you want to be or how understanding your audience is. Now, if I wanted to write the interval's not too bad. I only have one boundary, so I would say 0 is less than or equal to, because it's a closed dot, x. And that clearly shows, hey, I want every number that's greater than or equal to x, so that's the inequality. And so lastly, we want to take a look at the interval. Well, my left-hand boundary is still a 0, so that doesn't change. Put the comma down there. Now, my right-hand boundary is a little interesting. Arrows filled in means it goes on forever, which means it goes bigger and bigger and bigger. So anytime that happens, we're going to put infinity as my interval. On 0, the point is filled in, it's included, it gets a bracket. And then here's where we have to be careful. I'm going to write this as a note. In interval notation, parentheses, or gives the infinity parentheses, always. Parentheses will never have a bracket, so automatically I can go straight to throw my parentheses in there, and that's what I'm looking for. Okay? So again, not too bad. We're just writing the same interval as before, except now we throw parentheses anytime we get infinity. Okay? Last thing I'm going to show here, I'm actually just going to show it in interval notation, because I don't think we need to see it in all three cases. But I want to talk about what would happen if you have multiple parts. So I'm going to draw my number line in. Let's go 0, -1, -3. Let's make a closed dot here. Fill in the arrow. And then over here, let's go +1, filled in, +3. So suppose I've got some weird function, maybe it's a piecewise function, maybe it's something else, and this is the domain that I'm interested in. These are the intervals. Well, like I said, I'm going to jump straight to just interval notation. And so the key is I'm going to build it in parts. And I'm just going to go from left to right. So over here I have a filled in arrow, which means infinity, but it's pointed to left. So I'm actually going to put negative infinity. And as we just talked about, in interval notation, infinity always gets parentheses. So I'm going to put that parentheses on there, put my comma, and I keep going up until -1. And that's a closed dot, which means it's included, so it gets a square bracket. Okay. Next interval, I'm going to jump up. I'm going to jump all the way to a +1. It has an open parentheses, so I'm going to, or open dot, so I'm going to give it parentheses. Put the comma there. I go up until the number 3. Also an open dot, so it's unincluded, so it also gets the parentheses. First order of business, I have 2 intervals that are describing the set that I'm interested in. So 2 options for what you could fill in there. You can put or, I know, a big upside down or a big U stands for union. Either is acceptable. Most people are more comfortable writing OR, but if you put this in there, you're saying union, which you're basically saying include both sets. This problem also highlights the one downside for interval notation. There's a chance your interval could look like an ordered pair. If both points are not included and they both have parentheses, that looks like an ordered pair, which means you have to be really careful about the context of your problem. You need to think about what the question was asking, you need to think about what makes sense for your problem, and pay attention to that. In a nutshell, for interval notation, you're always going from small to big. Open circles or unincluded points get a parentheses. Included points, points that are part of your graph, get a bracket. And then anytime you have infinity, it's always going to get parentheses. If you have multiple sets, just throw a big U in the middle for union, or you can write out OR.